everybody okay with up to this point? We know that these two bridge statements are true. Yes? Okay. So then the question is, which one do we use, and then how do we express it? I think you can see, to get the position of the watermelon, there's two ways. We could use x equals v0t plus 1/2 at squared, or we could use v squared equals v0 squared plus 2ax. Right? The position of Superman is pretty standard. If I write that here, we know that's going to be vst. We know that to be true. Does that make sense to everybody? Now, for the watermelon one, does it make sense that this and this goes away? Because the watermelon started at rest. Well, if I look at this then, if I don't know, what the heck, this becomes 1/2 at squared. This becomes v squared over 2a. Now, if I bring this into this equation, if I set them equal to each other, then I can see that I have this final velocity of the watermelon is unknown, and the time is unknown. So if I, with this one, then I'll have two unknowns, and I got to come up with another statement. So I'm not immediately saying I shouldn't do that, but I'm just going to hold off for a second. Now, if I look at this one, I see the only unknown here on the right side here is t. And if I look at Superman's position function again, I see the only unknown is t. Well, do you see how this is pretty easy if I just solve for t? So I say, okay, you know what? And I'm going to say t squared is equal to vst. And then that'll knock one of the t's out, and I get t is equal to 2vs over a. And so Superman was what? So that's 7. So it takes 7 seconds for this to happen. And now I'm supposed to find the velocity of the watermelon, yes? Well, why not use the easiest equation that I have? So then I say the velocity of the watermelon, and of course that goes away to 0, is going to equal 10 times 7, or 70 meters per second.